Now let's look at this composite function from another angle or so. Remember that we said f composites with g of x equals f of g of x. Another way to kind of think about that is, again, imagine we have some input x. We run it through a function called g, and what pops out? G of x, its solution. Now we're going to take that solution, its output, and run it through another function. So it now becomes an input into another function, in this case f, and its output becomes f of g of x. So let's look at these two functions that we have here, and let's see what f with g, or composites with g of x, looks like. So remember, we have f of g of x. So let's look at our original function, f of x. Whoops. Everywhere we have an x, or every value we put it in to the remainder on the right side. So on this next time, we're going to have f of g of x So I'm evaluating the function f at g of x. And that's what my composite says, f of g of x. To reduce that out, let's look at this equaling 3. What's my g of x function? It is x squared minus 2x plus 6. And so you can see I have the g of x function embedded within my f of x function. Then we go ahead and reduce that down, distribute the 3 across. Lastly, I can combine some constants. And there we have the composite function of f with g, or f composed with g of x. Notice that I took my regular function f first, and I took the g of x and embedded that into my f of x function when it was written this way.